I'm really happy to be here today. I have two guests, Geoff Lentner, data scientist in research computing, and Preston Smith, the director of research computing. So before we begin, I just want to kind of remind everybody a little bit about our Master of Science in Business Analytics and Information Management program. I'm the academic director for that. It's an 11-month program. It starts in June, it ends in May. It's a STEM certified program, meaning that if you're an international student, that gives you a 3-year OPT extension. Basically, the program's designed to give students a great experience on, how to use state-of-the-art information technologies and analytical methods. Currently, students are using software tools such as MySQL, Python, R, SAS, Tableau, and Hadoop. And there's other technologies that we're using as well. But one of the things that really, a lot of students like to talk about our program is these projects, these experiential learning projects with companies. And this year we've actually had quite a bit of success. We had 19 posters accepted at Inform's Business Analytics Conference, and there was only 33 spots for student posters. So that was insane. They won first place in the poster competition and they won third place. We had another team that got selected for the top 8 at SAS Global Forum, and we've done a lot of great stuff as far as experiential learning projects with companies, but we could not do what we do here at Purdue without these two guys right here. So these are the guys that kind of make sure we have sort of the architecture and platform to be successful. Can Preston or Geoff, could you tell me a little bit about research computing and your role there?
That's good for you.
Is that for me?
Yeah.
So our research computing group here at Purdue provides central supercomputing services and support for researchers all over the Purdue campus. We have approximately 185 paid faculty investors who invest their own startup or grant money into using our supercomputing resources, and over 1,200 active users who have used those systems to get some kind of science done.
One of the platforms, or one of the capabilities that we use from you guys not only in our classroom projects, but also with some of these industry practicum projects is Scholar. Can you tell the audience a little bit about what Scholar is all about?
So Scholar is effectively a small version of one of our big supercomputers that's dedicated entirely for instructional use. So over the recent years, we've seen more and more instructors wanting to teach the concepts of high performance computing or data analytics relevant to their domain, whether they're teaching bioinformatics or weather modeling or business analytics. Everybody at some level needs high-end data storage, high-end computing to be able to do computational science in their field. Since it started in about 2012, it's grown from just a couple of classes to over 50 classes using it each of the last couple of semesters. I think over 3,000 students use Scholar during the spring semester of 2019.
Well, I can tell you 82 of those 3,000 students were BAIM students, and I know we use it quite a bit. So last year we purchased and tested a high-performance database server from you guys that we use for both classroom projects and projects with industry partners. We felt we kind of needed a secure environment where it was kind of our own resource. Were you guys surprised at all about kind of the usage from Krannert and say our masters in business analytics students?
I wouldn't say we were surprised per se, but historically our user community has been from the physical science and engineering. So their computations and their needs are all kind of a certain way. They're doing modeling and simulation mostly. We've been well aware of the amount of data-intensive data science things that happen over here in Krannert, and they're driven by databases, they're driven by processing large text files, which aren't necessarily things that we've historically done a lot of. But as the scale of the data analytics needs grow, they'll start to edge closer to high-performance computing, and high-performance computing is going to move closer to data analytics. So it seems like a logical intersection.
Yeah, I totally agree. So some of the projects we worked on this year, we had great performance, but there were some projects where I felt like maybe we needed a little more under the hood. So this coming year, we're actually going to purchase a cluster from one of your community clusters that's going to be dedicated just for our program. Can you tell the audience a little bit about your community clusters?
So the community cluster program is how we've been able to build large supercomputers in a cost-effective manner for the university to use. Many of them are broadly usable supercomputers that 85% or so of the users on campus can take advantage of, but several of them are kind of tailored to the particular community that needs them. For example, we have one system that's designed with every node having large amounts of memory. So if you need to solve a very big analytics problem or bioinformatics, that's a great system for that. We just built one named Gilbreth here in 2019, which is a 50-node system with 100 GPU accelerators in it, which is perfectly suited for doing large machine learning and artificial intelligence applications.
Say you're working at a company, we have some partners that maybe they're not as analytically mature as, say, a company like Amazon, right? Most companies aren't there yet. But I know a lot of our partners are trying to get to that point. They're trying to grow their data science capabilities. And to do that, they're considering investing in some of these high-performance systems. How would you say research computing's architecture and resources would compare to kind of what's state-of-the-art out in industry?
Yeah, so one of the key differences there, so for a lot of companies that are growing and developing a data science team or a data analytics practice will get the resources and infrastructure they need from something like an Amazon or an Azure. And the key difference here is that there's there's so much less complexity involved, and there's no credits and trying to stitch together, spin up a virtual machine and bring together some other kind of data system, whether that's storage or a database. Whereas here on campus at Purdue with BAIM and elsewhere, these are real physical machines that are on campus that students and researchers get direct access to. So there's no virtualization. It's bare metal. It's always up. And it's cost effective too, because it's not per CPU hour. It's you buy into a shared resource at a quite frankly very affordable price in comparison to some of the commercial cloud options. So students get direct access. They can log in directly on the command line or from an application like RStudio Server or Jupyter Hub. And there's no wait time. It's always up and it's right there.
Yeah, and just from my experience mentoring a lot of these different projects this year, not only do we have great access to RStudio Server and Jupyter, Python, we also were able to interface quite seamlessly with other tools such as SAS, Tableau, and other things. So, if there's companies out there that are considering trying to do sort of, big data analytics kind of project with us, something that might require high performance computing, just know that we do have the resources here because of research computing to scope out those kind of projects with our students. Is there anything else that you'd like to let people know about research computing that that kind of separates you from or highlights what you guys can do?
Yeah.
I guess just to build on what Geoff was just saying about, if somebody's going out to create an environment like this on their own, you build something on the Amazon cloud, for example, you stand up your own resources, and it's all up to you to solve these problems yourself. What I always tell people on campus that the key value that we provide in research computing is not just the infrastructure. Like Geoff says, it's very large, it's always on, it's very reliable, but we also have a team of dedicated staff like Geoff in a variety of scientific domains that are there to help consult and solve your problems, translate your science needs into data analytics solutions and help you get science done.
Okay. Well, thanks a lot, guys. The MS BAIM program is so thankful to work with you, and I'm looking to continue to grow our relationship in the future.
Yeah, absolutely.
We're glad to be a part of it.